केलकर साहब नमस्कार, नमस्कार श्रीवास्तव जी।
नमस्कार, नमस्कार, नमस्कार।
Am I audible to all?
Yes,
Yeah.
Yes, yes.
Yes, sir.
Namaste.
Namaskar.
साहब
Lakshman ji, Mahapatra ji, namaste.
महापात्रा साहब को
नमस्ते सर।
नमस्कार सर।
सर को नमस्कार।
नमस्कार, उनका बहुत बहुत बधाई
This
हो
is
बहुत
very
बड़ी
absolutely,
उपलब्धि के लिए।
absolutely.
आपका ब्लेसिंग।
वो तो सब ठीक है, लेकिन काम भी करना चाहिए ना। काम तो आपने किए हैं तो अच्छे कार्य है, तो परिणति तो कहीं होनी चाहिए। अच्छा, बहुत अच्छा लगा। It's a kind of global recognition.
we are proud of this. Yeah.
Yes.
Yeah. So good afternoon, everyone. I think we can start this session. And first of all, namaskar and very warm welcome to all of you. We IMD in collaboration with AIDMI has come up with this particular roundtable conference, particularly highlighting the our celebration with respect to 150 years of IMD, Frontiers for Early Warning. And I am very happy to coordinate this session. And it's an honor and privilege to see so many great people in front of me whom I have been seeing, learning during my entire journey in IMD and for that also. So just to give a brief outline about this particular virtual roundtable. So as you all are aware that IMD has completed 150 years of its foundation. So and a lot of achievements have been attained by IMD in with respect to early warning services. Its accuracy in forecast has improved, actionability has improved a lot. Now it's all about this event is about to understand how the frontiers of early warning and anticipatory action, when we are considering 150 years of IMD, are able to reduce the loss and damage to at-risk population, and how further they can be improved upon to have a better services and all inclusive services for the people at large. So first of all, I will like the opportunity to introduce the very esteemed panelists over here. So I will like to first of all introduce introduce Dr. M. Mohapatra. He is DGM IMD, Technical Meteorology, Indian Meteorology Department. Dr. M. Mohapatra is renowned for his advancements in cyclone forecasting and strengthening India's early warning systems for weather and climate-related disasters. And I, on my personal behalf and behalf of everyone over here, once again like to congratulate Dr. M. Mohapatra for receiving a very prestigious United Nations Sasakawa Disaster Risk Reduction Award, UNDRR Sasakawa Award for 2025. It has brought a lot of accolades for Indian Meteorology Department, Ministry of Earth Sciences, for all the countrymen with respect to disaster risk reduction. On this particular moment, I will also like to highlight a small video just to give some small introduction regarding the award and that ceremony, so that we could at least relive those moments again of those moments of pride. So I will request Dr. Mr. Manish if he can share the video of that award ceremony which happened in Geneva, in which this prestigious award was given to Dr. M. Mohapatra, DGM IMD.
Yes, just a minute.
In 1971, a devastating cyclone hit Orissa, claiming 10,000 lives. Among the survivors was a 6-year-old boy, Mrityunjay Mohapatra. That tragedy shaped his life. Years later, he joined the Indian Meteorological Department with one mission: to save lives from the fury of cyclones. Today, that child is known as the Cyclone Man of India. But it was the 1999 Orissa supercyclone that marked a turning point. Dr. Mahapatra vowed to transform India's cyclone warning system. As the head of the Regional Specialized Meteorological Center and Project Director for Weather Forecasting Modernization, he brought groundbreaking changes, advanced models and longer lead times. The real test came in 2013 when Cyclone Philene threatened the coast. His accurate 5-day forecast enabled massive evacuations. This time, only 22 lives were lost, a sharp contrast to the thousands before. He pioneered impact-based forecasting, tailoring warnings for farmers, fishermen, infrastructure and disaster managers. His people-centric approach brought accuracy, clarity and trust. Dr. Mahapatra also revolutionized communication, using SMS alerts, mobile apps, social media to reach even the remotest corners. Today, as Director General of Meteorology and Vice President of the World Meteorological Organization, he champions global resilience through initiatives like Early Warning for All. From a cyclone survivor to the Cyclone Man of India, Dr. Mrityunjay Mahapatra's journey is a story of science in service of humanity.
Thank you. Yeah, just to share that particular video where that award ceremony was telecasted. Manish, do you have that video or shall I share it?
Namaskar, good evening, good morning, and good afternoon to all of you. Your Excellencies, Dr. Kamal Kishore, Head of UNDRR, distinguished members of UNDRR, the Nippon Foundation, esteemed jury, and dear colleagues. I am deeply humbled to receive the 2025 UN Sasakawa Award for Disaster Risk Reduction. This honor reflects not just my journey, but the collective efforts of India Meteorological Department and the communities we serve. I thank the Honorable Prime Minister of India, Sri Narendra Modi, and the Ministry of Earth Sciences for their unwavering support in advancing our early warning systems to serve not just our nation, but the entire region. I am grateful to my dedicated colleagues in India Meteorological Department, sister organizations in Ministry of Earth Sciences, various experts working within the country in academic and R&D organizations, and also the international agencies, including UN bodies, WMO, and many government and non-governmental sectors, and above all, the general public and stakeholders. I am also truly grateful to my family who have stood by me through every storm which we have witnessed. Growing up in Odisha, an eastern state of India, I saw the wrath of cyclones, floods and droughts as a son of farmer in my childhood. As a 6-year-old child, I witnessed a devastating cyclone in 1971, and I was among the few survivors. The experience shaped my resolve to work towards saving lives when I joined India Meteorological Department and took over as head of Regional Specialized Meteorological Center for Tropical Cyclones, and finally led the modernization program of India Meteorological Department to ensure early warning to be accurate, timely, and effective for early actions. Today, India is raising the bar in the world of extreme weather forecasting, issuing forecasts at an unprecedented spatial resolution and higher accuracy. It is working towards delivering the weather services at each and every household. It has ensured the early actions following the early warning, not only for cyclones, but also for most of the hydrometeorological hazards affecting the entire region. More importantly, our early warnings are no longer one-way messages. Fisher folks, farmers, urban and coastal communities are now active participants in the risk reduction process. They are prepared, they are aware, and they are resilient. This award renews our commitment to the Sendai framework for disaster risk reduction. We will continue to strengthen science, empower communities, and ensure no one is left behind. Thank you for this recognition and for your belief in our shared vision and mission for the entire world. Thank you very much.
Thank you very much. And okay, so now going for the panel members, we have with us Shri Rajendra Singh sir, member and head National Disaster Management Authority. He is a leading authority on disaster management in India with extensive experience in policy planning, risk reduction, and emergency response coordination. Hearty welcome to you, sir. We have with us Dr. R.R. Kelkar, sir. He is former Director General of Indian Meteorological Department. He is a distinguished meteorologist known for his leadership in modernizing India's meteorological services and promoting particularly satellite meteorology and communication. We welcome you, sir, over here. We also have Dr. L.S. Rathore, Lakshman Rathore, sir. He is former Director General of Meteorology in the Meteorological Department. He is an international expert in weather and climate services with decades of leadership in science, policy, and agrometeorology. We welcome you, sir, over here. We have with us Dr. U.C. Mohanty. He is Distinguished Professor at Diksha Aur Anusandhan, SOA University. He is a pioneer in numerical weather prediction, climate risk management, and urban forecasting. He has significantly worked in advancing India's weather and climate services. Welcome you, sir, over here. And also we have with us Mr. Mihir Bhatt. Mihir R. Bhatt leads the All India Disaster Victim Institute, AIDMI, which works at the intersection of humanitarian action, disaster risk reduction, and climate resilience. He works at shaping public policy, building local capacity, steering innovative pilots, supporting evaluation, monitoring, and learning, and co-creating bottom-up knowledge for common use. I welcome him also as he's the co-organizer over here. And I'm very thankful for him for bringing out this particular roundtable conference. So now, before going ahead, I will also now request Mr. Manish to kindly share the screen with respect to special issue of AIDMI South Asia Disasters, that magazine, which is focusing this particular edition, focusing on celebrating 150 years of IMD, Frontiers of Early Warning. The link for this magazine is provided in the chat box. So you can see the articles which are available in this particular issue. So this can be accessed through the link provided in the chat box. Okay, so if now going to the discussion for which we all have gathered over here again, now taking again the current scenario of 150th celebration of IMD Frontiers of Early Warning. I will now first invite DGM IMD Dr. M. Mohapatra to share his views in view of 150 years achievements of IMD, his recent award, and what are his thoughts about the future progress of Indian Meteorology Department. Over to you, sir.
Yeah. Namaskar, good afternoon, good evening, and good morning to all of you. I say that this particular conference is being participated by various experts and individuals across the globe. I, at the outset, express my deep gratitude to all of you, all the experts, all the people, not only in our country, but also the entire globe, who are working continuously for reducing the risk due to the disaster. The recognition which has been shown here is a true reflection of an integrated approach of the entire community, where each individual is a very, very small creature. So therefore, the credit goes to all the experts, all the organizations, institutes, individuals who have contributed to this story of the success, not only in India, but also entire region, especially South Asia, Southeast Asia, Middle East, Asia Pacific nations. So gone are those days when people died in thousands and lakhs. The story of the cyclone hitting Bangladesh, Bhola cyclone in 1970, if we remember, that was the heartbreaking when 300,000 people died. And now we have come up to a stage where there has been zero death due to the cyclones like Dana and Viparjaya in 2023 and 2024. So this history has been wrought by the mankind, and especially this DRR community, including early warning communities, the community for preparedness, prevention, mitigation, and the community providing the capacity building for the individual and the organizations. So therefore, I am really grateful to all, including the political mass and the common people. I want to express my deep gratitude not only to our present colleagues, but all our predecessors, commencing from the day when the cyclone warning commenced, that is in 1865, after the devastating cyclone, in the form of the port warning from Calcutta. And now we have come up towards the states. I think among us, we have Dr. L.S. Rathore and Dr. R.R. Kelkar, who have long history of knowledge, and they will share with us their experience, expertise towards these frontiers of early warning while celebrating 150 years of India Meteorological Department. We have come up a long way. There is a significant improvement with respect to each and every severe weather, not only in terms of monitoring, but also in terms of forecasting, its accuracy, its lead period, and its reachability to each and every individual in the region. It has benefited all the region, especially South Asia, Southeast Asia, Middle East, in terms of the guidance being provided daily with respect to all severe weather and early action being taken by the various communities, all these countries. Therefore, I also congratulate all the countries involved in the region for crossing the barrier and raising our status in terms of the reaching the frontiers of early warning while celebrating this success. While doing so, there has been many initiatives and activities in the past 1 year to celebrate 150 years of India Meteorological Department. And finally, it was the Honorable Prime Minister who delivered the keynote address to the country and the region and to the globe on 15th January 2025. The journey of celebration commenced with the address by Honorable Vice President on 15 January 2024. During this journey, we have tried to develop various activities in terms of the stakeholders interactions, interaction with academic and R&D institutions, interaction with the common people, and also bringing out the documentations, the movies, to track the achievements, the gap areas, and the future plans. This year has been marked with many such achievements in terms of awards and recognitions by the international community and within the region also. The recognition given to this individual is a recognition to each of us. There has been also a study of the current status, identification of gaps, and the plans for the next few decades, especially when we travel towards the 100 years of our independence in 2047 with a vision and mission. The Vision 2047 has been released by Honorable Prime Minister, and all of us were witnessed towards that event. While carrying out all these activities, Mir Bhatt came forward and gave a good suggestion that we should bring out a documentation. I'm really grateful and thankful to Bhatt for proposing this initiative, and which is culminating today in terms of a brainstorming session and release of a special issue of the newsletter. I congratulate Mir Sahab and all the lead authors and experts who have contributed towards this release of the journal. And also I congratulate all the panelists, those who have joined today in the deliberation to understand the frontiers of early warning while celebrating the 150 years of India Meteorological Department. I express my deep gratitude to Sri Rajendra Singh Sahab, member and head of National Disaster Management Authority. He has been a symbol of pride. He has been a symbol of success. He has been a symbol of leadership. Under his leadership, National Disaster Management Authority has made a quantum jumps in terms of the early actions following the early warning. Thank you very much, sir, for not only believing in early warning, but ensuring the country and the region to believe the early warning. NDM has played a very key role while organizing the early actions for each and every severe weather events based on the early warning being provided by India Meteorological Department. Be it the heat or cold wave, or heavy rainfall warning, or the thunderstorm or cyclone warning, NDMA has been in forefront to integrate, organize, and initiate actions by not only NDMA, but also all the state emergency operation centers, state disaster management authorities, and overall the stakeholders and general public. We are very much thank you, sir, and also we are grateful to you and your entire team in National Disaster Management Authority. I also express my deep gratitude to Dr. R.R. Kelkar, former Director General of India Meteorological Department. He is a grand old man at present, and his life itself is a story of India Meteorological Department. He brings out the live discussion and live testament of the various successes wrought in different phases of India Meteorological Department. We are really grateful to you, sir, because of your leadership and inspiration provided over the years, not only in India Meteorological Department, but to the entire community in the region. I am also grateful and express my deep gratitude to Dr. L.S. Rathore, the former Director General of India Meteorological Department. And he has many caps also, like Dr. R. Kelkar Sahab, internationally and also within the country. So his leadership, his inspirations has led to development of many young minds into mature minds. All of you, what you see today in India Meteorological Department, they have grown up with the ambitions and objectives and leadership and inspirations of our former Director Generals, starting with, if you ask me, I grew up in India Meteorology Department with Dr. R.R. Kelkar as DG IMD, and prior to that, Dr. Sen Rai. And after that, there are many, including Rathore Saab, Dr. Ajit Tyagi Saab, Dr. K. Ramesh Saab, and I'm really grateful to all of you. And Rathore Saab has made very significant contributions while communicating science to the people. His initiative towards agrometeorological services, early warning to the farmers, has made India proud, and it has been a symbol to be followed by many countries. Similarly, the contribution of Dr. R.R. Kelkar Saab in communicating science to the people is visible to everyone if you look at his blog page, if you look at his contributions. I'm also thankful and grateful to Professor U.C. Mohanty, the renowned and distinguished professor who has developed a generation of meteorologists. There are many who have carried out PhD with Professor U.C. Mohanty in the field of atmospheric science and allied sciences, and I am among them. So I'm really grateful to be a student of Professor Mohanty, and thank you very much, sir, for helping India to have the capacity in terms of the human resources. And also, you have organized many events to improve the capacity of the various organizations. And you are the person who was behind the introduction of numerical weather prediction in the country in 1994. And we celebrated that in 2024 in NCMRWF for 30 years of operational NWP. Though it started with Dr. P.K. Das, then DG of IMD, in terms of application of numerical weather predictions in IMD, and first paper came in 1958. So all these things shows that India Meteorology Department has become vibrant throughout its journey and has provided the contribution in terms of the science, technology. Say, for example, if we talk of the El Nino and La Nina, the development of this or identification of this large-scale process came from India. Similarly, if you talk about the introduction of radar, it came from India Meteorological Department. So like that, the satellite. So people might be thinking that Indian Space Organizations is the premier organization for satellite applications. I will say no. It is the India Meteorological Department who brought satellite in the country first. So we brought the satellite, we purchased the satellite at that time when there was no Indian Space Research Organizations. And of course, thereafter, Indian Space Organizations has become a leading role in improving, augmenting, and providing applications of satellite in terms of the meteorological applications. Now I express my deep gratitude and thanks to Dr. Mihir R. Bhatt, the director of All India Disaster Management Institute, for his inspirational leadership, for his motivational role, for his collaborative approach for each and every other organizations. And especially I will talk about India Meteorology Department. We have been immensely benefited with the collaboration of AIDMI, with the leadership of Sri Mihir Bhatt. He has been always a visionary, thinking the issue in terms of the grassroots, providing the inputs and igniting the minds in India Meteorological Department to serve the people better in terms of its outreach, in terms of its products, in terms of its services. The accuracy, the actionability, and the accessibility of the forecast and early warning to the people has improved over the years because of the contributions of people like Sri Mihir Bhatt and many others. We are open in India Meteorological Department to receive. We are good listeners, bad or good, and that enables India Meteorological Department to introduce the new science and new technology to reach out to the people for early actions and hence to minimize the loss of lives and also enable the people to improve the socioeconomic conditions, not only at the individual level, but also for society and the country. So with this, I will stop here because I want to listen more from all the experts present here. Once again, I welcome and express my deep gratitude to all our panelists and all the participants, those who are making it successful today while celebrating 150 years of IMD and discussing the frontiers for early warning. Thank you very much.
Thank you, sir. Thank you very much for giving a very nice background of IMD's historical evolution, as well as providing the current agenda setting for the rest of the sessions. Now, I will request Shri Rajiv Singh, sir, head and member NDMA. As we all are aware that NDMA and IMD work in close coordination. So, sir, we all want to understand from you how this IMD and NDMA collaboration is unique and how it is important to the world, sir. Sir, are you available? I can see him in the, but I don't know probably. Rajan Singh, sir, are you able to hear us? I think probably
I was contacting him. He could not. So we can proceed with the next speaker. In between, he can join.
Yes, sir. Okay, so now we are going forward to Dr. R.R. Kelkar, sir. Sir, he has already mentioned about the, kind of information and source of inspiration you are for all of us. So we'd like to understand the evolution of meteorological services in India and how you see the future scenarios with respect to these services of IMD, sir.
Thank you, Akhil. It's good to see you again. And special thanks to Dr. Mahapatra for speaking about me with so much of affection. It's good to hear sometimes the words of affection from people like Mahapatra. And it's good to be here. Now that I'm speaking out of turn, I've got a promotion kind of thing in the line of speakers. So I'm the first speaker in a sense after Dr. Mahapatra. And I'm not going to speak much. I'm going to ask many questions. At my age, we are kind of privileged to ask questions rather than give answers to them. So we had a lot of celebrations. I'm almost 2 years of continuous celebrations. The Honorable Vice President, the Honorable Prime Minister have come and blessed us. We have had a tableau in the Republic Day parade. Thousands of people have seen how IMD works. We have written articles everywhere, and I've been part of the whole thing. So it's a good thing to be part of IMD. And it's a kind of a IMD history is now in the public domain. Anybody can find out what it is. But there are two dates in 150 years which I always remember very well. Two dates in 150 years. October 29, 1999 is one date. And July 31st, 2002 is another date. I'll explain what these dates are. In fact, these are, I'll call watershed moments in the history of IMD because they changed the way in which IMD functioned. So these two dates, and I happened to be there in IMD at that time in Delhi. So October 29, 1999 was the Orissa supercyclone about which Dr. Mahapatra spelled out in detail. And in spite of good forecasts, pinpointed forecasts, we had a loss of 10,000 lives. So this was something which shook us that what is it that we should do? And the second thing is July 31st, 2002, when the country experienced a rainfall deficiency of minus 51%. This was unprecedented, and we had given a forecast of a normal monsoon. So this was something which shook us again. So these two dates of October 29, 1999 and July 31st, was actually led to a lot of soul searching, not only within the IMD, within the government circles as well. And one of the things which happened was the setting up of a high power committee for disaster management, of which I was a member. And this committee had worked for a couple of years. It had a lot of meetings, and that finally led to the setting up of the National Disaster Management Authority. Not only that, there was a very bold decision of the government to transfer the mandate of disaster management from the Agriculture Ministry to the Home Ministry. This was a major policy change which things became better. At the same time, IMD in parallel improved its cyclone warning capabilities quite a lot. And so the result today is that the number of deaths is nearly zero in the case of cyclones, for which, of course, IMD and Dr. Mahapatra are getting awards. The other thing about the monsoon was that long-range forecasting was totally revamped. We had a 16-parameter model, and that was dispensed with, and many other models came in. We had monthly forecast, homogeneous regions forecast, probability forecast, dynamic prediction. So many things have happened. Then came the monsoon mission, and now we have the mission Mosam. So this is the brief history of IMD of 150 years, which I summarized in 2 days, that after this, everything changed after these 2 dates. So today I have only questions and no answers. I'm going to put them in 3 sets. One set of questions about cyclones, the other set is about monsoons, and the third is about social media. So please permit me to put these questions before. This is a virtual roundtable, and there are experts who can, I think, address these issues. First of all, I would like to talk about the effect of climate change on tropical cyclones. There is so much of scaremongering these days, especially on social media, that because of global warming and climate change, the number of cyclones will increase. This is a scary situation. Also, their intensity will increase, or both may increase. But the reality is slightly different. Last year, for example, we hardly had any cyclones worth their name. This time, up to today, we have had just one simple depression. So public should know what is exactly happening. Are we afraid of the future, or we are safe with the future? So I would suggest that IMD and NDMA should bring out a position paper on what climate change is likely to do to tropical cyclones and what we should be prepared for in the coming years. Because then the public doubts will be set at rest. Otherwise, everything becomes kind of a scare. And even for policy planners, in what direction we should go. So this is one suggestion which I would like this roundtable to consider. The second is about cyclone landfall over metropolitan cities. See, so far we have never had the occasion to give a landfall point in any of these metro cities in our coast. We are lucky, on grace of God, I should say. But supposing you have to give a landfall point, and it's a hypothetical case, you're supposed to give a landfall point between Santa Cruz and Colaba tomorrow. How are we going to deal with that situation? Something that I think needs a lot of consideration, because the population of Mumbai is like 2 crores. Where are they going to be taken? I mean, we have heard of 30 lakh people being evacuated on the coastal belt, but Mumbai is a city which has 2 crore population. Where will you take them? How will you take them? Not only that, when you bring them back, what will be the state of the city? I mean, supposing Mumbai does have a cyclone landfall, what will be it like? How will you bring back the city back to life? So these are the questions I think which need to be addressed. And maybe this particular gathering can do that, or we can even have a kind of a workshop on it later on, because we should address them. The second set of questions is about the monsoon predictions. In 1988, we had a 16-parameter model. It went on for almost 14 years until we gave it up. But the error bars, which were there in 1988, which is 37 years back, still prevail. And this is something which worries me. I mean, the 16-parameter model, we talked of plus or minus 4%. We still talk of plus or minus 4%. So my question is, how can we bring this even to 3% or perhaps to 2%? That will make a tremendous difference in credibility of this forecast. Because now what has happened is, these figures like plus or minus 8%, plus or minus 5%, plus or minus 4%, or plus or minus 4 days for the onset of the monsoon. These are comparable to the standard deviations. And the forecasts become comfortable because they have a large margin, so they can rarely be proved wrong. So I think we have to reduce these error bars to the minimum so that the public will believe, and we can do something about it very specifically. So this is one point I would like to this roundtable to address what we should be doing about reducing this error bar. The second worry that I have is about long sequences of normal monsoons. Like prior to 2002, we had something like 13 years of a normal monsoon. God's grace, I should say, or nature's grace, I should say. But then in 2002, we went wrong because we had given a prediction for a normal monsoon and it was completely different. This year, we have had 8 years of good monsoons in a sequence. It's a long sequence of 8 years. And it is just common sense. I mean, I don't have a model. It's just common sense that nothing good lasts forever. So you are going to have a drought sooner or later. And if it is later, fine. If it's sooner, it's bad. So we should have a plan for that. If there is a drought here, how will we handle it? Not only that, we have come out of the agricultural ministry to the home ministry. A home ministry cannot handle a drought. It is only the agriculture ministry which will handle a drought. So are we going to go back for a year of drought, or are we going to continue and the home ministry will take care of drought? I don't know. So this is something that I think people should deliberate upon and come to some kind of a term. So we should have a roadmap of how we deal with a drought situation. My last set of questions about the social media. Social media now extremely active. Nobody can keep their mobiles away. And what happens is the social media are accused of misinformation and exaggeration. This is a very common thing on social media, especially about the weather, because people want to know about the weather as if something wrong is happening with nature. And immediately that is put on the social media as a breaking news that here it has rained, which has never before rained in any time. And sometimes the record-breaking events are like once in 30 years, once in 10 years, once in 2 years. How can once in 2 years be a record? But people are projecting things that once in 2 years, this has been a record. So this is something, and we have lots of amateur weathermen on YouTube. They're not only English, they're around languages like Marathi. It's not like a dozen weathermen on YouTube who keep on talking all the time. And much of it is not at all realistic. So like this time there was a low pressure area, I think a low circulation. Immediately it was projected into a cyclone named Shakti, not by IMD, but by the YouTube forecasters. And people say Shakti will come here, it will go there. And so the thing that is to be done is that we have to put some kind of a tag on these things. The second thing, I mean, it's not misinformation, but disinformation. And this is done by private companies who are in the business of weather. And their only aim is to prove IMD wrong. I think on both these accounts, IMD has to take a stand as to how we deal with these situations, and the country should have a policy. So IMD needs to be vocal, and many times when these people are vocal, we are sometimes not that vocal, we are a bit silent. So these are the points that I thought in 10 minutes I should present before you. I don't have answers to these questions, but people now, I think, as we go in the round table, some questions may emerge, or at the end of the discussion, we can think of that. So I'll stop here. Thank you.
Thank you very much, sir. Those were really very pertinent and very important questions, which requires a lot of deliberation to find out the solutions and some way forward. Let's put that. I think we will have this discussion here also and outside this roundtable also to find and see what kind of solutions could be seen in the near future. Now, I'm taking opportunity to invite Dr. L.S. Rathore, sir, regarding the topic on the top 5 early warning agenda items for India. When we are considering it in respect to 150 years celebration of IMD, what in his views are top 5 early warning agenda items for India?
Thank you, Akhil, and namaskar to all. Would you kindly share the presentation, or I would share myself? I don't know.
Manish, will you be sharing the presentation?
Yes, just a minute.
Okay, in the meantime, when it is being shared, I really take this opportunity to thank the organizers for this very beautiful way of celebrating 150 years of IMD and taking the bull by horn by choosing such a beautiful subject of frontiers for early warning. The warnings are issued for extreme weather events. For normal weather events, we give forecasts or predictions or whatever you choose to call it, but warnings have a different meaning, and therefore it also put a lot of urgency in organizing follow-up actions, and therefore it need to be communicated to the intermediaries, disaster managers and institutions, and public at large. And different people have to play different roles in chewing the warning. And next, please. So can you thank you very much. When it comes to the warnings, the first and foremost, there are two components, rather three components. Component number one is it is the quality of warning which decides the quality of actions. And therefore, and when I say quality of warning, it directly leads to the skill of the weather forecast. And the entire paradigm of observations to data assimilations to modeling to post-processing to forecast preparation and forecast dissemination, the entire spectrum is part of that. And in that process, the first step is the observational system. Currently and globally, let me tell you that the meteorological fraternity is facing financial crunch. That is my observation. But fortunately, in India, we are very fortunate to have a visionary leadership in government who are really helping the Ministry of Earth Sciences by giving a lot of funding support, and therefore onus is on the meteorological and hydrological community to smarten its system. And most of the investment, the large chunk of investment goes to establishment of observational system and maintaining that, and then data communication. There are a large number of issues which are related not only to augmenting the observational system, but we have to focus on enhancing the observation use efficiency. And when I say this observation use efficiency, it has different components. I've just briefly mentioned about few of them. There may be more. First and foremost thing is, while we establish the observation network, we need to have a deep understanding of the network design of observations, and therefore accordingly optimize the observational network. More often than not, we fail in doing so, because we work from the point of view of ease of operating the observation systems, and therefore ignore the mountains or deserts or difficult terrains. And we pay the prices for that. And I'll give you a striking example of India, where we have very few observations. I mean, till recently, there were hardly any observations in the entire Himalayan region or even Western Ghats and even the Thar Desert. Now only we have realized the importance, and we are in the process of augmenting the observational network with the due recognition of the processes which are happening over there. For example, in the desert, we have very sparse observations, whereas it is the seat of the monsoon trough zone, and the trough also fluctuates. If you look at the trough from both the ends, the western end migrates north and south very with a large amplitude, and also the western disturbances and heat lows and whatnot. It determines the strength of monsoon through the pressure gradient it sets over the western coast of India. So that is one aspect. And aspect number two is the data quality issues. More often than not, we compromise with the quality of sensors, and for want of a denser network, because the money is limited, and therefore it has jumped. Oh, sorry. And therefore, it is, I'll give you an example. When we were working at National Center for Medium Range Weather Forecasting, when we were in the process of data assimilation, the radio sound day of at that point in time, we had 40 stations, around 40 stations, and the data were being rejected time and again, both 0 UTC and 12 UTC. And the data assimilation group, they flagged that issue, and there a lot of debate, and it took us a lot of time to convince the upper air sections of IMD that no, to improve the quality of radio sound, and subsequently we started importing. The whole point I want to emphasize is that it is the quality of data more important. Of course, density is important, but when it comes to compromising, we should not compromise the quality, and therefore we have to have a robust quality control mechanism. And let me again tell you, today when we do the data assimilation, most of that large chunk of data is from the satellite. And satellite is not the meteorological parameters, but it is the radius, and therefore we do radius assimilations. But again, the quantum of rejection, if you look at both surface, upper air, radar, satellite, entire spectrum of data, it is quite huge, and we should really take cognizance of that, and it should minimize that, because the investment we are made in these observational systems are huge, and if we are not able to make use of data, I think it is time to have a look at it. So also the data assimilation system, and data assimilation system, of course, if there is error in data assimilation, it magnifies in the forecast system, and therefore the whole aspect is we are at the juxtaposition of transformation in the meteorological processes. Not only the observing systems, but the communication systems, the modeling, everything is going to have a sea change, and it is already happening, and we are fortunate to take advantage of that. So in the whole process, next please, we need to deploy new techniques in these aspects. Next aspect is better understanding the atmosphere and its relationship between ocean and land, and therefore better understanding of the land surface processes. Professor Mohanty is here, and air-sea interaction, troposphere and stratosphere interactions, data assimilation and modeling I have already mentioned, and post-processing is also very important, and most important I consider being man of applications, the application of weather forecast into different sectors of economy, because howsoever good information is you are generating, but if you are not able to make use of information has no value, and therefore applications are equally important. Next please. The initial condition is the critical factor in weather forecasting, early warning, and they are subject to errors due to limitations in observations, data assimilation techniques, and severely at times impact the skill of the forecast. And then we adopt various tools to minimize that error, be it a joint method or observational system simulation experiments or convex optimizations. But there are two aspects, because in the initial conditions, if you look at spatially, if there are errors, look at the spatial distribution of the error. And when you extrapolate in both time and space in terms of forecast, the spatial domain of the errors, initial errors, also magnifies it differently in different parts of the forecast zone. And so also the forecast duration, because the sensitivity of the forecast to initial conditions which impact the forecast duration, not only duration, but it at times minimize or sometimes it magnifies. And so therefore, it require optimization strategies that account for increasing the influence of these errors over the temporal range of the forecast. And now we need to have AI and ML, which are being explored, but we need to have more focus on that. Next, please. Model development is constant process, and I must congratulate Ministry of Earth Sciences, IITM, IMD, NCMR, everybody, and IITM scientists have now given us Indian model Bharat forecast system. My sincere compliments to that. But this is a constant endeavor. We are working towards that. But again, there are certain core areas which we need to focus in order to resolve the atmospheric processes, and one of them is a parameterization process, or improving the skill of extreme weather forecast. That is where the gray area is. General forecast skills are better, but when we really look at the skill of extreme weather forecast, we find ourselves in a very tricky situation. And lastly, the sectorial impacts of different weather forecast and parameter-wise forecast. For example, a cyclone. When cyclone comes, we look from the point of wind aspect, from precipitation aspect, from storm surge, from flooding, and the combined effect of the cyclone over how it is going to cause the disaster. And therefore, vulnerability assessment, everything goes in the background, but they are the prime important areas. But when you do the applications, like for example in agriculture, the forecast to be linked to the soil moisture simulations or crop simulations, or in flood forecasting guidance, it is again the precipitation forecast has to be linked to these kind of. We are doing that, but that process for other sectors need to be strengthened. Next, please. Models can't resolve everything, and therefore we need to understand the behavior of model in the recent past, and that is done through the post-processing tools and the model output interpretations. And because that also is a big science. When we started at National Center for Medium Range Weather Forecasting, we thought of model output statistics, but model output statistics we couldn't deploy. And Dr. Mahanti is here. We resorted to PPM, perfect probe methods, because there the change in the model is not impacted. But the large groups, both at NCMR, WF, and IMD and IITM, are doing the ensemble forecast, and that's really helping. Good bias corrections are done, good downscaling is done, all well done. But there are new techniques which we need to deploy, particularly artificial intelligence, because and the data mining, machine learning, these are the techniques, because they can now understand how the model has been behaving in past few seasons or years, in different seasons and different initial conditions. And building on that strength, we can really minimize a lot of errors which are found in the skill of the numerical weather output. Next, please. So model output visualization and the modernization, Dr. Tyagi is here. He took the lead role in initially visualization and deploying visualization and synoptic tools like synoptic chart, where we have a comprehensive look of various kind of information in front of a forecaster. But still we have miles to go in that. That also need to go for next higher orbit. I mean, we have done a lot, but forecast refinement process also is very continuous process, and we need to further improve our model output visualization tools. Next, please. I think this is my last slide, and the warning dissemination is very critical. Dr. Kelkar also has emphasized, Dr. Mohapatra has also emphasized. And when we say warning dissemination, it is a comprehensive package starting from hazard monitoring to forecasting. And we have talked about some of the tools and forecast technologies. But when it comes to dissemination, we need to know as to whom we are disseminating and how vulnerable that group is, what are the risks involved with that. And also the dissemination has to be multi-level warning, which we are doing now. IMD is doing a great thing in warning dissemination, but considering the size of country and also variety of groups who are vulnerable, our reach out is still demanding more efforts. And so therefore we need to have a better improved communication with a proper feedback. Unless we have a real-time feedback and an analysis mechanism, we will not be a very effective communicator of the warnings. And for that, we need to analyze what are the communication barriers and how to strengthen the institutional frameworks, because no single agency can reach out to all the groups, and the content of the warning and the language of the warning is equally important. And we have seen in many times that though the forecast was accurate, but their content and language were not comprehensible to the user group, and they faced the brunt. Next, please. Thank you very much for patience hearing, and if there are any questions, I'll be able to address that at that later point in time. Thank you very much.
Thank you, sir. Thank you for a very enriching talk, sir. I will just say, it was very enriching. It covered all, touched upon all the main phases of forecasting, including observation network, going up to the dissemination part. And one crux, which is very important, is quality of warning affects the quality of action, sir. Thank you very much, sir. So now going forward, now I would like to invite Dr. UC Mohanty. He is a pioneer in numerical weather prediction services. He will be talking about the evolution of numerical weather prediction for weather services. What are the key achievements and what opportunities are present for this particular sector? Thank you, sir. Over to you, sir.
Thank you, Akhil. Can I get my PPTs?
Yes, sir.
And very good afternoon, and also very good evening and morning to participants from other parts of the world. So it is really a great privilege for us to have this roundtable meeting, which is very, very important and very successful. And I thank the organizers. And first of all, I join with all of you to congratulate Dr. Mrutyunjay Mohapatra, DGM, for the highest United Nations award, that's Sasaka Awards, for the disaster risk reduction. So I will focus now, because already a lot of things have given by my predecessors, who are really the DG for several years and with their experience. So I will tell the evolution of Endolphi for weather services and how it was really successful, and now what we are getting the fruit of the success, how it is linked to the numerical weather prediction. Next, please. Next PPT. Yeah, so I cannot stop myself by showing the most earliest numerical weather prediction that was made by a British scientist in 1922. It was not successful, but it was the first attempt by Sir Louis Richardson. At that time, there is no computer was there. It is only a handheld PCs were there. So he was using Albert Hall like a concert and trying to make the prediction by the numerical models. But it was really not successful. Next, please. When you go to the numerical weather prediction, and now actually, I will elaborate how numerical weather prediction is penetrated to weather and climate systems and its more accurate digital informations, which can be translated for the service of the mankind. It has major three components, as also it is elaborated by Dr. Ratosab. First is the initial condition, because any forecast, whether it is synaptic or climate or numerical, it is initial conditions. Initial value problem is the numerical, is the theme of the prediction. So initial value is most important. And as you all know, that with modernization of IMD and many other advancements, so our observations have enormously increased. The quality has also improved, but still we could not able to use all the data, and as many efforts are required to synthesize the data and make it use. Another thing that when you go to the initial conditions, the regional models, mesospatial systems, then you also bound with conditions. That is also one of the problem, but which is now successfully solved. And other thing that the data is not in irregular points, and we need the data assimilation. So data assimilation is one of the vital points in the initial value generation. The next is the dynamics and physics of the model. We use hierarchy of models, starting from mesoscale models to that global models, and from atmospheric model to coupled models. And these models have various resolutions, and most important, the physical processes which are sub-grid scale, which are less than the grid size of the models, which have to be parameterized, and most weakness of the numerical weather prediction in the parameters and physical processes. And third, but the most important thing, the application, post-processing. The model can give only 7 variables or 7 parameters, 3 components of the wind, temperature, moisture, pressure, and density. But that will not serve all the purpose. We need cyclones, it's a track, we need the visibility, we need the many other things, as you know. So therefore, post-processing is one of the very vital point also on the like the past initial conditions. So then we have to do the system diagnosis. We have to make bias corrections, because every model has its own bias. Some are the systematic and some non-systematic. System bias have to correct it. Location-specific forecast is very essential for its application by any individuals. And then the forecast itself is not exact. So we have to make it probabilistic, which is achieved by ensemble and super ensemble approaches, and so that we can tell the prediction of suppose precipitation, how much it is accurate, 80%, 50%. Is cyclone going to hit a coast? What is the probability of it crossing that coast or other side regions? Next, please. So if we see the development of the weather prediction models, first it started in 50s, and first successful forecast was made by Jules Verne and Van Neumann in 1950 at Princeton by using machines, that electronic machines. And that time we are understanding only the atmosphere. We are taking barotropic model. India is not far behind, because 1958, Professor P.K. Das and his team, they use also a non-divergent barotropic model for its prediction in Indian region. Then came in 80s atmosphere with land. As Dr. Rathore told, land is a very important part of the atmosphere, and that feeds the moisture, and the land process was introduced in 1980s. Then along with the land, we need the ocean. So ocean is also introduced in 1990s. That is a couple land ocean atmosphere models are developed. And in 20s, we have also ice cover and various aerosol things in the atmosphere. And then it is very recent, till 2001 or so, for the climate models, we are using also chemistry, carbon, sulfate, sea ice, and many other factors. So like this way, the models are developed around the world. Each components were developed and they are plugged in. And now we are coming to have more and more accurate models as we move in the time. Next, please. So these models now also used in a seamless manner, because it has various use. all sectors in the society. I tell that is the beggars in the street to president in the palace, everybody need with the forecast of different type. So therefore, there's a need of a seamless forecast starting from minutes for the aviation services, for hours, for the players in the cities, or days, and weeks, and months, seasons, and climate change. Where is the forecast from 1 to 10 days? That is, we call the weather prediction, where initial conditions plays a very important role. But if we go to more, that is S to S, that is sub-seasonal to seasonal scale, which is we call the climate prediction. But it is prediction for 2 weeks, 4 weeks, or a month or season. That is very much used for planning purpose, and like a reservoir management, or planning for the agriculture aspects and so on. So all these things also need the climate prediction, where boundary conditions like the sea surface temperatures or snow cover and many other factors, they play a very important role. And these have the applications in various sectors. And as you know that there's no sector where the weather and climate prediction is not required. Next, please. But we need all prediction, but the skill of the forecast is not so. The probability is not so. It is if it is a short scale, like a day or two, with the forecast, up to 3 days forecast is very accurate. It may be 70, 80, 90%. But as we go in a time, like a monthly forecast, or 2 weeks or 3 weeks forecast, then it is substantially decreased. But it is little bit increased as a seasonal forecast we go, and seasonal forecast, because we know that seasons are more stable than the weeks and months. So the scale is divided in the way as we move in the time. Next, please.
What a class over?
Yeah, so then you see that the schematic diagram of the model, that you can see it has a atmosphere, it has a surface, it has a land, it has the ocean, and so on, and they very intimately interact each other, and that have to parameterize. And it has a impact in various sectors like agriculture, ecosystems, runoff for the river flooding, and so on. Next, please. So as we go in time, our area of forecast also increases. If I want to predict a thunderstorm at a particular point, I don't need a global model, because it is a one-day forecast, a few hours forecast. But if you go beyond 3 days, then we have to predict for the whole globe. And that is how the forecast in India developed. First, we started with a barotropic models, as I told, and then actually we moved on, and a new era, next please, developed when we have a, this is the gamut of models, please leave this and go to next. So these are the various observation systems, because you know that only 1/3 of the area where we have the land surface, 2/3 area is the either oceans or the snow boundaries or mountains where we cannot get observations. So maximum observations we get from satellites. That is what already pointed out. And but all these observations are assimilated and put together so that we have a comprehensive picture of the whole atmosphere, so that it can be predicted more accurately. Next, please. This is again various type of forecasts that I have already told you. Next, please. And when you go actually tropics, we are very stable. We are not like in London, where in a day we have 4 times rain or 4 times sunny. We are in the tropics. We are very stable. But with that, also we get many severe weather systems, that is extreme weather events. There are damage starting from tornadoes and flash floods, avalanche, to that of the droughts. And these all have to be predicted by the hydrometeorological models and also systems. Next, please. So if we see the economic value of the cumulative economic value, that is the survey by business today, the maximum loss is due to tropical cyclones, followed by the floods, earthquakes, severe weathers, and so on. And with the impact of the climate change, the variability is increasing more. It is not the number. Like a tropical cyclone, we are getting more frequent, not more frequent in our region, but intensity is increasing in several cases. Similarly, the thunderstorm and lightning, that is a dramatic change because it is now more occurring not in pre-monsoon, during monsoon time, summer monsoon time, which gives a lot of casualty to the people working in the field. So on, flood and drought, heat wave. As you know, this year it was a really havoc for the many parts of the world. Many cities we have the heat wave conditions, and only good thing that the cold wave conditions have decreased. Next, please. So if I come to the success story of the numerical weather prediction and its applications, definitely it is already emphasized now. When I prepared this PPT that time, Dr. Mahapatra has not received the award, but this is the most success story for us in the tropical cyclone forecast. As you know, over the whole global tropical oceans, we get 80 to 100 tropical cyclones, but Bay of Bengal, a tiny basin, which get only 3 to 4 or 5 cyclones, which is 4 to 5%. But if it's casualties due to tropical cyclones, in last 300 years, 74% of the tropical cyclones having the death toll of more than 5,000. If we calculate 74% of such cyclones occur in the Bay of Bengal, which actually have less intense cyclones compared to the typhoons and hurricanes. India has made substantial improvements, substantial developments, but we started with very simple things, as Dr. Mahapatra told that in 1874, 1864, but then we started statistical models, then barotropic models, and so on, then mesoscale models, IMM5, WRF, HRF, global models are now in the process of developing an Indian land, ocean, atmosphere coupled system. So these are the development of the models in several years, and until 2003, forecast methods were subjective at IMD. They are coarse resolutions and they are quasi-Lagrange models, and we have not a definite track prediction. And that was very well documented by Kelsey and others in 2006 and Mahapatra et al. 2013. So since 2008, we have very accurate series forecast. In fact, I remember the days when NDMA started, and we developed a document for NDMA under the leadership of the then member, Dr. M. Sashidhar Reddy, and we are asking IMD that whether we can give exactly 50-kilometer errors in 48 hours. That was really a very dense problem, but now it is not so. Next, please. I will tell you some improvement in tropical cyclone forecast, which is already told by others maybe. If we see 1999 Odisha super cyclone, which was the only super cyclone of that century, and about 10,000 casualties were there. And this was the track by various models. You can see that how coarse they are. But after just 14 years, when we have a similar, almost similar cyclone Thalin in 2013, which crossed the Gopalpur coast, again Odisha coast, you can see the up to 5 days forecast is almost dot. So therefore, IMD could give comfortably the forecast for the 5 days that time for the Thalin, and which associated storm surges, because maximum casualty takes place in the Bay of Bengal due to the storm surges. So this is what was possible, and casualty was reduced to only 22. Next, please. Similarly, another very dangerous cyclone was the Fani, that is again crossed Odisha coast and passed over the land for a long distance, and that was in April, May 2019 over the Bay of Bengal, and that also predicted almost not up to 4 to 5 days in advance. Next, please. Similarly, another super cyclone was occurred in Bay of Bengal in May 2020. You see that in these days, cyclones also occur with very significant intensity in also pre-monsoon period. Generally, we tell post-monsoon period is more with a strong cyclones, but pre-monsoon also we got many cyclones, like I have shown you, Fani, and also this Amphan. This was also very successful predicted. The bottom one is that like a track that predicted by IMD, and also the probability of its landfall with the different grades where it is 80% chance, where it is 20% chance, where it is 10% chance, where it is 60% chance. So this gives the people the confidence that where they will have to evacuation, where they have the watching, where they have to take specific action. And this forecast of every 12 hours things, you see all are following on the same path and all are telling that it will cross to the West Bengal and Bangladesh coast. So that was the success that achieved in the period of this about 20 years or so. Next, please. So if you see the little list of the casualties, which again emphasized by all of you, that is starting from 1999 when 10,000, of course I have not shown you here, Nargis, which crossed the Myanmar coast, having about 1.4 lakh people perished due to that cyclone. But we have now in 2020 the Vipaja in the from Arabian Sea in the west coast, and recent year 2024 Dana in the Odisha coast having zero casualties, which is a dream of all of us when we started joining the meteorological department or meteorological research. We all are aspiring that whether we can achieve that same. But now it is achieved and is well recognized, and we are all very glad that Dr. Mahapatra was able to achieve that thing and bring the glory for our country. Next, please. Another thing, actually, now you know that with the global warming, the city forecast is one of the very important aspects. And in particular, to forecast in city scale, which will be sub-kilometer scale. So now sub-kilometer scale models are developed. And in fact, in 2019, we started this thing jointly with CDAC, IIC Bangalore, IIT Bhubaneswar, and few other IMD and few other organizations. Our objective is that how in the city scale, like Dr. Kekal showed, like a city like Bombay and so on, how in the city scale people can know, or the managers or the evacuators or the city management authorities, they can make a decision support system where to evacuate the people, where to take actions, and how to save the life due to the many severe weathers in the cities, in particularly the heat stress, that heat waves, and heavy rainfall leading to the flash floods in the cities. Next, please. So this is just I'm showing a story of success. This is the case of the, we have taken here sub-grid scale, that is 500 meters scale grid size, and we have taken 3 cities, Pune, Bhubaneswar, and Bangalore, and we are comparing it the success rate of the urban mesoscale model, where the land use, land cover plays a very important role, as you all know, and then how much is the false alarm and how much is the success that can be achieved, so that people can get proper warning. So here I'm comparing the global models, which is of course very high resolution, 12 kilometer, with the 500 meters urban model. And here you can see the success rate is quite high. That is almost more than 70%, and 28% exactly. And then the first warning only 30% or so. Next, please. Similarly, also for the city of Bhubaneswar, also we have shown a heat wave conditions. But I think my time is over. So yes. Next, please. So I conclude my talk with this, that is the success now, the changing climate, and we have more and more challenges, and as compared to that what we are facing earlier. And though we have a success in the tropical cyclone forecast, thunderstorm, casualty to thunderstorm, or heavy rainfall, it's still a challenging problems. This needs the strategies like enhancing the observations, which I think Mission Mausam is going to take care perhaps with more radars and surface observations, more frequent data assimilation so that we can have more rapid data assimilation systems. Impact-based forecast is almost ultimately required, which IMD already started, and dissemination same to the local authority and stakeholders is very essential because it masses our country is concerned. Then I congratulate IMD for the success in tropical cyclones, and we all hope in few years we can also solve the problem of lightning and flash floods, so that more casualties which is occurring now due to the lightning and flash floods can be reduced. And achieving these advancements will require close collaboration among operational agencies, research and academic institutions, local authorities, and international partners. With this, thank you all for your kind attention. Thank you.
Thank you, sir. Thank you for a very enriching lecture, sir. And it's always a pleasure to listen to you, sir, talking about NWP. We have always been motivated by your lectures, sir. It's very informative, sir. Thank you, sir. Now, going again to head NDMA, Shirajin Singh, sir. Have you joined, sir? Yeah, so thank you, sir. So,
Hi, Akhil. Thank you very much. Good evening, everybody. And I'm extremely sorry. During that 3 o'clock, there was a meeting called by PMO, and Mr. Tarun Kapoorji was chairing the meeting regarding the two accidents that have taken place out at Arabian Ocean, the two ships. So there was a meeting on that issue. So I have to attend that meeting. I'm extremely sorry for that. And as far this this talking point is there, I will just finish in 5 and 10 minutes. You got time, Akhil?
yes, sir.
Okay.
Sir, actually, we are very glad that you were able to join us, and we were eagerly waiting to hear from you. So we were
Yeah,
actually.
but there was a PMO meeting at exactly
Yes,
at 3 o'clock, so I have to leave and I have to put you on hold. But
Thank
that
you, sir.
meeting was DG Shipping and other agency was there, so I was not able to come.
Thank you,
So
sir.
it
Thank you,
is,
sir.
it,
You are able
it is
to.
both an honor and responsibility to speak at this historical occasion of celebrating 150 years of the Indian Meteorological Department, Frontiers for Early Warning, and for inviting me to share thoughts on IMD and DMA collaboration, why it is unique, and how it is important to the world. For me, or to me, this is not just an anniversary, it is a moment to pause, reflect, and project ourselves into a future with renewed purpose. I extend my deepest appreciation to IMD and AIDIMI for convening this roundtable on a most timely theme. Let me begin with the quote by Honorable Prime Minister addressed at the Asian Ministerial Conference in 2016 in New Delhi, where he said the aim should not just to manage disaster, but to prevent and mitigate them. The time has come to embrace the culture of risk prevention and resilience. That vision of moving from reaction to resilience, it is the guiding light of the IMD and NDMA partnership. As per NDMA guidelines on the management of specific disasters, IMD is the nodal agency for early warning generation in several key hazard domains, like cyclone, under the guideline of cyclone risk management in 2008, flood is CWC and IMD under the guideline of flood risk management in 2008, same heat wave under the guideline of 2016 and 2019 guideline on heat wave, cold wave, dust storm, thunderstorm, lightning under NDMA advisory and action plan. And finally, the urban flood under the guidelines on urban flood risk management 2010. These guidelines empowered IMD to generate real-time alert, impact-based forecast, and hazard-specific advisory, while NDMA coordinate preparation, mitigations, and emergency response, ensuring policy coherence and action of synergy. This clearly delineated mandate has helped eliminate duplications, ensure faster decision making, and enhance accountability. How this collaboration is unique. What makes our collaboration is exceptional is not just its formal structure, but operational depth and trust-based agility. IMD, how IMD is important for NDMA. IMD scientific excellence ranging from synoptic scale, cyclone forecasting to machine learning based rainfall prediction feed directly into the NDMA preparations and response strategy. Together, we move from alerting to acting. IMD giving us alert, and we are acting on this. And we have seen during the every major cyclone, such as Fani in 2019, Amphan in 2020, and Biparjoy in 2023. A virtual control room is formed between IMD and NDMA. Every bulletin, every impact advisory, every press communication is synchronized. This seamless interface has unique to our institutional culture. And now forecasting with purpose, planning, and precision is very, very important. Whether it is urban flood forecasting, pilots in Bangalore and Guwahati, or heat wave mitigation plan in 250 districts. IMD data inform NDMA's policy. The result, early warning that saved livelihood, and dignity of our people. Our collaboration has led to a better risk communication through TV, mobile alert, bulletins, WhatsApp group, and volunteers like Abda Mitra. Early warning are not abstract anymore. They are personal, local, and actionable. And it is always trusted by our communities. And how it is important is second thing I like to say, how it is our collaboration is helping us. If internationally we see, it is our collaboration. IMD and NDMA collaboration is aligning with Sendai framework for DRR, that is 2015-2030. Our partnership directly advances priority number 4 of SFDRR, that is enhancing disaster preparedness for effective response and to build back better recovery. More specific, if I talk about the target D, increase the availability of an access to multi-hazard early warning system by 2030. Our co-led expansion of multi-hazard alert system integrating IMT forecast into NDMA's disaster dashboard is a model others are copying and others are studying from India. The priority number 1 is underlying disaster risk. IMD new tool like impact-based cyclone advisory and risk map combined with NDMA national risk database are building a scientific data-driven understanding of vulnerability. Number 2, advancing the PM 10-point agenda on DRR. Our collaboration, let me recall 3 specific points from the Honorable Prime Minister 10-point agenda, first articulated at Asian Minister Conference in 2016. Point number 1, all development sector must imbibe the principles of disaster risk management. Our joint work has ensured that climate-sensitive sector like agriculture, health, water, urban planning now use IMD early warning for better risk informed and planning. Point number 4, invest in disaster risk mapping and early warning system. India has made massive investment in Doppler radar, lighting detection network, flood warning system, and mobile-based alert dissemination, demonstrating the principle of our actions. Here, I would like to say, sorry, there's something has happened here. Yeah, and the point number 6 is talked about our developed a network of universities to work on disaster issues. Here, I like to say through NDMA partnership with academic institutions and IMD, growing engagement with IITs and NITs and state university, we are building a next generation knowledge and innovation ecosystem. Honorable Prime Minister and Chairperson of NDMA and Home Minister Shri Amit Shah ji, who is the Minister of NDMA, has stated in the annual conference in Relief Commissioner meeting, I think in 2023, where he mentioned early warning should not remain in file and control room. It must reach the farmer, the fisherman, the family, and that is our real success. And finally, I would like to share my 3 points to you. Let me now underline 3 key takeaways, which I believe should anchor our collective vision for the future. Point number 1, early warning is not just a forecast, it is a life-saving decision. We must stop viewing early warning as end-to-end product of scientific efforts. It is the starting point of a life-saving action chain. For example, during the 2023 heat wave in North India, IMD timely alert enabled NDMA to trigger advisories across the state, closing school early warning, the early developing ORS kit, and coordinating with health ministry. The forecast become a strategic decision in our country. Point number 2, I like to say, the strength of an early warning system lies in its last mile reach. Early warning must become early action. It must be understood, trusted, and acted upon by our common citizen. My third point will be when institutions collaborate selflessly, nation build resilience collectively. There are no tough war between IMD and NDMA. There is no room for silos. What we have a culture of a mutual respect and shared mission. This is perhaps the most important lesson for this world. For every country seeking to build effective early warning system, our model shows that collaborative governing works, especially when powered by science and anchored in community. Lastly, I want to thank everybody and given me this opportunity to speak. And I like to say Harivansh Rai Bachchan has once said, and he said, लहरों से डरकर नौका पार नहीं होती और कोशिश करने वालों की कभी हार नहीं होती. In this journey of disaster resilience, we will face uncertainties, but if institutions like IMD and NDMA continue to navigate together with courage and clarity, no wave is too high to storm to grace. Thank you very much, Akhil, for giving me this chance. Maheshji, namaskar to you.
Thank you, sir. Thank you for very nicely articulating the relationship between IMD and NDMA, sir. It's very rightly said, sir. It's a relationship of cooperation, coordination, mutual respect, leading from alert to action, sir. Thank you very much, sir, for providing those wonderful words, sir. Now, going forward, now I will, first of all, open the floor for the questions if anyone has from the audience, and go further. We'll take up the concluding remarks and we head from Mir Bhatt. So, do we have any questions, answers, or any comments from the viewers, listeners?
Let's
So, I guess probably floor is yours, Meher Bhatt.
Okay, I think if you have any questions, please do email that to us and we'll make sure that you get the reply to that because there's a lot of material which has been discussed and will take some time to absorb. No, my name is Mihir Bhatt. I work with All India Disaster Mitigation Institute, and I'm immensely happy to have this event today, celebrating 150 years of IMD, especially focusing on Frontier for Early Warning. I've been requested to look at the way ahead, and I'm going to do that in the following way, with your permission. One, I'm going to look at the overlap between IMD's mission and NDMA's mission, both very important to our country. The overlap area, what is it, the 4 or 5 things that we should be doing? So that's first. Second, what I'm going to do is to not talk either as a disaster expert. I'm not a meteorological person at all. I'm going to talk, make the list based on user of the meteorological advancement that are there and early warnings that we receive. I'm going to make the list based on the urban regional planner. And third, if I may, make the list as a friend of the people who are working on this particular area. So that's where I'm coming from. Of course, I have considered the Sendai framework, and of course, I have considered the revised NDM Act. But I'm also going to Rajendra Singhji's 3 takeaway points. So keeping that in mind, I'll do a quick way ahead, that where is it that we can focus our work on within the mission monsoon and within the Prime Minister's 10 points that we have. So keeping that in mind, the first which came up in the Rajendra Singhji's presentation is the next generation of impact-based and affected people-centered forecasting. And that's something where expand IMD's shift from hazard-based alerts to impact-based alerts and sector-specific forecast, such as health sector, education, industry sector, employment, of course, and citizen-specific forecast in terms of vulnerable groups, such as small businesses, farmers, urban poor, especially small farmers, urban poor, etc. So that's the first possible way ahead. The second possible way ahead, and I'm drawing from Kelkar Saab, your presentation here, and of course the work that is presented in the special issue that was released today about 150 years of IMD, and that is strengthen the last mile and last person as well, multilingual alert impact. So how do you make the impact of that and ensure the early warnings are actionable and at the community level by using mobile apps such as Sachet, which we see that in the field being used and feel so happy that it is actually being used in such a large scale. Many more can use that. Local media and the trusted networks. I recognize the point which was made here about many other YouTube early warnings are coming up, and somehow a way of making them more authentic and controlling when the authentic data is not there. And also the formats are very important for strengthening this last mile and multilingual alert impact. So that's the second way ahead. The third way ahead that I hear today, and I see it's very useful to move ahead, and there I'm drawing Rathod Saab from your presentation especially, and that is firmly integrated forecasting with the decentralized early action and financing. especially when the Finance Commission is looking at what to fund. I think the work here will be very important to connect the IMD alerts with anticipatory action that NDMA is proposing and promoting, the protocols which are also coming up, and forecast-based financing tools which are available, piloted, and now could be done at a much larger scale. So the civil society actors such as us can act before hazard strikes, minimizing loss and enabling timely support, and in the long run, reducing vulnerability itself. So it's not only a early warning, but it's also actually reducing vulnerability as part of the warning. So that's the third area. Two more areas. And the fourth area, I'm drawing from the presentation you see Mohanty Saab, and recognizing the tropical cyclone success and how that success could be spread to other areas. What I see that is enhanced regional and cross-sectoral network collaboration. That is promote collaboration with further collaboration with South Asian and Indian Ocean partners to tackle transboundary climate risk, strengthen ties with sectors such as power, transboundary, health transboundary, education, urban planning of the city to city, and employment and agriculture. So basically to embed forecasting into decision-making across the region. And that's the fourth way ahead. And fifth, the list is large, but I'm focusing on the overlap between IMD and NDMA area. So I'll stop there after the fifth. And that is to invest in decentralized, seamless, and bottom-up technologies, citizen science, and indigenous innovation. And then I'm drawing from some of the discussions and work that we have done with Shri Ajit Tyagi, Tyagi-sab, some of your discussions I'm using here, and use AI, for example, real-time data for mobile sensors and citizen-generated observations, for example, to improve forecasting accuracy. Encourage public-private people partnerships for expanding weather infrastructure and foster innovations rooted in local knowledge and action system. So that's the fifth one. And it has a very broad base, and I don't need to point out, but it also reaches much larger number of citizens at a time. So it is the not Indian Meteorological Department only reaching out to citizens, but citizens, hundreds, thousands, millions of them reaching out and owning up the parts of the meteorological forecasting that is taking place. So the fifth one broadens the base of participation of Indian citizens in what we are doing. So I think from the forecast to early action, and from science to safety, and from data to dignity of the affected population, that is something what is coming out for way ahead. Thank you very much. I'm extremely honored and proud to be part of this discussion and this celebration. Back to you, Akhilji.
Yeah, thank you very much. So finally, I think if anyone else want to comment, say something, or otherwise we will close this meeting. And it was a wonderful celebration for 150 years of IMD, and also the award of DGM IMD Dr. M. Mohapatra is the UN Satsagawa Award. So anyone wants to say something, or can share we can close the meeting.
We will be putting together a report of this, very short report first to start with, and share with everybody. The discussion here will be on YouTube as well for people to use it. Any other suggestions anybody has, please do send us, and we'll include that in the Way Ahead program. And we are developing a larger program on early warning and disaster risk reduction for everybody to use. That will follow. Thank you.
So may I ask a question?
Yes, madam.
Yeah, thank you very much. It was very interesting session. I just wanted to know, maybe I joined a little bit late, maybe because of that I could not make out. what I saw after joining this session is that mostly we were talking about the storms, the flood forecasting, and all those things. Is IMD also involved in drought early warning systems?
Yeah, thank you very much, madam. Drought is also a disaster, and it is a slowly evolving disaster. And the nodal agency for the drought is the Minister of Agriculture. So what we do as nodal agency for weather, we provide the information on rainfall monitoring information, rainfall forecast information. For this purpose, we give location-specific rainfall, district rainfall, state rainfall for the past 24 hours, or past 1 week, or past month, or past season, and that continues. Almost 130 products are generated every day by IMD with respect to rainfall. Then also we provide the forecast, seasonal forecast, expected rainfall during the season, say monsoon season. We were told this year that all India it will be above normal rainfall. That means we are not expecting all India drought. So these are some kind of derived informations. We are expecting good rainfall this year. And followed by that, we give the monthly rainfall. For example, we have told that in the month of June also we'll have good rainfall activity, that is above normal rainfall activity in the month of June for the country as a whole and different parts. We also predict rainfall in different parts of the country. It is not simply the country as a whole. Following the prediction for month, we go for every Thursday seasonal forecast, weekly rainfall forecast for next 4 weeks. So that is very important because it provides the wet spells or the dry spells of rainfall activity expected in different parts of the country. So by that way, the efficient rainfall in between the season or during the season also taken care by the prediction of that one. But as such, we do not declare drought or we do not go for predicting drought, but we predict the rainfall because drought are of different types. There could be the simply meteorological drought. That means rainfall is deficient, for example, at meteorological subdivision level by 20% or more. But there could be hydrological drought when it affects the groundwater and affects the dam reservoirs capacity or so many things. So there can be even a socioeconomic drought. Sometimes rich person, if he has got facility, he has got capability to purchase water, then he may not feel the drought. But the poor people, they may feel the impact of the drought. So therefore, and there could be another the agricultural drought. So that is left to Minister of Agriculture.
You mentioned that you are more into rainfall. So I have one more question, if you permit me.
Yes.
So you mean to say your most of your data is specific to rain only, and you do not, as far as drought prediction is concerned, do you also generate rainfall deficiency index values at different time scales? And
Yes.
that I know that you are generating, but is it available to the public?
Yes, it is available to the public. We have got a special monsoon page where we get all informations. We prepared the standard precipitation index. Also, we prepared standard precipitation evaporation index, that is SPEI, evapotranspiration index. And also, we've got aridity index. So there are many indices which are also prepared and given to government, and it is available to the public.
What is the resolution of that index value? Monthly?
At present, district-wise indices are prepared. District-wise.
And time periodicity?
Some are daily and some are weekly.
Okay, so daily basis you are giving that.
Yes.
Okay, sir. Thank you so much. Thanks.
Thank you.
Thank you. So, okay, if you want to say something?
Okay, you can take some questions from the chat box.
Okay, sir. So there's a question, is IMD doing predictions for Himalayan glacier melting and sea level rise?
Yeah, IMD is not the authority to provide the forecast for the glaciers, and there is an organization under Ministry of Defense, that is DGRE, Chandigarh, and they monitor avalanches and they give the forecast for avalanches. And with respect to the glacier status, Central Water Commission provides monitoring information. And there is no such forecast on the glaciers. The avalanche forecast is available. But the impact of the climate change on glaciers, all the information is generated by the nodal agencies, and Central Water Commission is the nodal agency for glaciers.
So there is a question by Archana, how we can get rainfall forecast information to the layman farmers in simple language?
Before that, I just mentioned that we give the information about the snow cover, and every day based on satellite we prepare the information about the snow cover area. The next question you are asking.
The question is how we can disseminate rainfall forecast information to the layman farmer in simple language.
Yeah. So there are many approaches which are being followed at present to reach out to the farmers in a very common language. For this purpose, at first we are preparing a product which is called as Agro-Meteorological Advisory Services product, AS bulletin. And this bulletin is prepared on Tuesday and Friday. And these are communicated through various means, including the website and the mobile app. We've got a mobile app called Meghdoot, which is available in local languages and along with English and Hindi. Apart from that, what we have done recent time, that we have gone for collaboration with the state governments. 20 state governments so far have collaborated by that way that agro-meteorological advisory services are being provided through the state level mobile app of these 20 states. Then there is another approach that we are forming the WhatsApp groups. We have kept a target that 5 farmers in any village should be connected with India Meteorological Department. So by that way, many villages have been completed, but yet we have to complete the entire country in that sense. And here, not only Tuesday, Friday bulletin is going, but every day there is a severe weather warning for the given district or block or panchayat, we provide this information to them. The third approach is that there are public-private participation, just like Reliance Foundation, IMS Swaminathan Foundation, and recently there is some other NGOs who have come up. So through them, we are providing information, localized information to the area where they are working. Finally, we have come up with Ministry of Panchayat Raj, where ward members, sarpanch, and panchayat secretary gets the weather forecast, and that also goes to the farmers. And also, we have come up with the collaboration with Ministry of Rural Development, where Pasu Sakhi and Krishi Sakhi, they are the women. The information is being provided so that they can further disseminate to the women involved in agriculture and also the people involved in agriculture and livestock. We're also now working with other ministries like livestock, etc. There it goes. Or inland fishery also, we are working with the organizations so it can. So there is a future plan so that each and every farmer can be connected with ours. In addition to that, there is Kisan portal of Ministry of Agriculture. Through there also information goes to the farmers. So there is a multi-pronged approach to reach out each and every farmer with the information in their own language and also contents oriented towards them. So as we know that for farming, we need the cloud cover, we need the sunshine hours, we need the temperature, both maximum and minimum, and we need the rainfall and other information. So accordingly, all the information are generated. It goes at block level at present, and panchayat level information will be provided very soon, and we are working towards that with the launching of 6 km by 6 km model this year. Thank you.
Thank you, sir. So for any other questions, I think you can just write on the email ID provided on the chat box, and the reply will be provided accordingly from the concerned expert panelist. So now I think we will be ending of the meeting. So I will take this opportunity to say thanks to all the expert panelists.
Yeah, there is one question. I'll just try to answer that because it is a regional question. Is there any mechanism for IMD to share transboundary weather forecasting for cyclone and flood? among SAARC countries and upstream downstream countries. Yes, since 2016, we are providing all severe weather event forecast valid up to next 5 days through South Asia forecast demonstration project. Now it is severe weather forecasting program for South Asia that includes 9 countries in South Asian region. Also, we have got the tropical cyclone forecast that goes to 13 countries in South Asia, Southeast Asia, and Middle East. Every day information is provided, valid for next 7 days in case of tropical cyclones, up to 5 days in case of other severe weather events. That includes winds, waves, and heavy rainfall and thunderstorms, related winds. So this mechanism is also being supported with the help of the capacity building. We provide training to all the member countries forecasters. And also, we are providing the observational support and modeling support, whatever available from IMD, by sharing them through website and also bilaterally, those who want the information from IMD. Thank you.
Thank you, sir. Thank you, sir, for all the elaborate replies, sir. Okay, so I think now we are not seeing any more questions in the chat box. So all are requested to kindly share any doubts, any questions, any information required on the email ID. So we will respond to that accordingly. Now I would like to thank all the panel members who have taken out time from their busy schedule and provided their provided a very wonderful talks over here. These talks have been very much enriching for me, for us, and for all the viewers and listeners over here. I hope it will be giving up again shaping the way ahead, how the forecasting, meteorological services, as well as disaster management actions will be taken ahead in the future time. Once again, I would like to thank all the panelists. Congratulations to DG sir for the award, and to all IMD people associated directly, indirectly, for completing 150 years, glorious years of services to the mankind. Thank you very much. So, Mihir Bhai, if you want to add anything, or we can close the meeting.
No, I just want to congratulate again to Mohapatra Saab and thank the panel for this excellent celebration and all the participants. It's really very proud moment for us, all of us, and we feel very.
I also join with Mir Bhai Saab in congratulating all our panelists and all our distinguished participants for today's roundtable discussions.
Thank you.
Thank you very much.
Thank you.